We'll continue. One more video. Actually, the salts of strong acid and strong base neglected, because when a strong acid combines with a strong base to produce weak conjugated base and as well as a weak conjugate acid. Okay, both are weak. Simply, NaCl is a salt of HCl and sodium hydroxide. As both acid and bases are strong, they are conjugates of Cl minus and Na plus ions. Both are weak. Their hydrolysis is always negligible and their solutions remains neutral. Their pH value also is equal to 7. Okay, now we will continue one more video that is called common ion effect. Common ion effect. What is common ion effect, sir? The decreasing the ionization of a weak electrolyte by the presence of common ion by adding of strong electrolytes. When a strong electrolyte is added to the weak electrolyte, the ionization of weak electrolyte will be decreased. Simply, the definition is decrease in the or suppression in the ionization of weak electrolyte. Decrease or suppression in the ionization of weak electrolyte by the common ion from strong electrolyte is called common ion effect. For example, AB is a weak electrolyte, which can dissociate its ions A plus and B minus. Positively charged ions are called cation, negatively charged ions are called anion. Now I am adding any strong electrolyte. If you take Cb is a strong electrolytes or Ad is a strong electrolytes, now I am taking these are the strong electrolytes. Okay, Cd is added to the equilibrium mixture, C plus and B minus. Okay, these two are common. Okay, this number of concentration, the number of moles of concentration of the product increases, the reaction takes place backward direction, ionization process will be decreased. That is a decrease or suppression in the ionization of weak electrolyte by adding of strong electrolytes. Or in case Ad is added to the weak electrolyte, Ad which can dissociate into A plus and B minus. Here A and A are the same common ions. Okay, concentration of A plus ion is increases. That's why the ionization decreases. For example, if you take here, now I am taking some example for common ion effect. You can observe here. That is simply AgNO3 silver nitrate. It is a weak electrolyte which can dissociate into Ag plus and NO3 minus ion. Now I am adding here a strong electrolyte in nitric acid which can dissociate its ions NO3 minus. So what is the common here? NO3 minus. These are the common ions. To take one more example, AgNO3, or if you take AgCl which can dissociate into Ag plus and Cl minus ions. If you take HCl molecule, H plus and Cl minus ions. Cl minus are common. Like that. Now I am taking one more example here. The example for common ions, acetic acid and sodium acetate, which can dissociate into its ions, acetate ion and H plus ions. Here, okay, what is the common here? Acetate ions are common. Simply decrease or suppression of ionization of weak electrolyte by adding of strong electrolyte by the presence of common ion. Presence of common ion. These are the example for so many examples are there. If you take barium sulfate, which can dissociate into barium plus an SO4 minus 2 ion. Okay, PbSO4, which can dissociate into Pb plus 2 and SO4 minus 2. These are the common ions. Okay, simply we can conclude that. So what is the common ion effect, sir? The decrease in the ionization of weak electrolytes. The decrease in the ionization of weak electrolyte by the presence of common ion. The decrease in the ionization of weak electrolytes by the presence of common ion from strong electrolyte is called common ion effect. Thank you. Thank you one and all.